All right, 7.3, we are working on binomial radical expressions. Tough to say, binomial radical expressions, 7.3. All right, so lesson preview, what are we going to learn today? We're going to learn to add and subtract from radical expressions, and then we're going to learn to multiply and divide the binomial radical expressions. So we should know what all those words mean so far. Only new vocabulary today, like radicals, which we will learn right after we do the skills check. So we need to be able to FOIL here. I'm going to do number 1. Just as a reminder, you're responsible for the rest. Remember that x plus 5 squared is x plus 5 times x plus 5, right? So make sure you don't just square the x and the 5. You've got to FOIL it all the way out. All right, first, 15x squared. Outside, negative 10x. Inside, 12x. And last, minus 8. We've got 15x squared plus 2x minus 8 when we collect our like terms. All right, so that's what we've got going there. Let's get into the lesson. Oh, make sure you pause this and finish up 2 through 6 before you move on. All right, so add or subtract if possible. Like radicals are radical expressions that have the same index. Remember, the index is the number up here, and the same radicand, number underneath. All right, so if those are true, we can add or subtract them just like x's. So remember, if we had like 5x plus 2x, we could make it 7x. But if we had 5x plus 2y, there's nothing we can do. We're stuck there. All right, so same thing here. Because on A, we have the same index and the same radicand, 3 and 3, x and x, we can combine these like terms. 5 minus 3 is 2, and then we have the cube root of x. All right, so the index and the radicand don't change. We're just going to add or subtract the coefficients. For B, root 2, root 3, the index is the same, 2 and 2, but the radicands are different. So we're stuck. Nothing we can do. We got to leave them separate. See if you can add or subtract A, B, and C, only if it's possible. All right, real world connection, let's see. This is a design for a stained glass window. What a beautiful stained glass window that is. Each small square is 5 inches on a side. Express the dimensions of the window and its perimeter in simplest radical form. All right, so from here to here is 5. From here to here is 5. Our job is to figure out the dimensions here so we can find the perimeter. Okay? All right, so one thing that we could do here is let's look at maybe this triangle right here. That might be helpful because then we could figure out how far it is from here to here. Okay, so we know, let me just draw this triangle out here, that this one would be 10 from here down to here, okay? And we want to know what our side lengths are. Now, fortunately, both sides are the same, so we could use our good friend, the Pythagorean theorem. A squared plus A squared, this would be an A, and this would be an A. And we know they're the same lengths, equals 10. So 2A squared equals 10. So A squared is 5, so A is going to be the square root of 5. All right, so if A is the square root of 5, there are 1, 2, 3, 4 of those triangle lengths along the side. So our length here is 4 root 5. Our height would be 1, 2 root 5. All right, so we have dimensions 4 root 5 by 2 root 5. The perimeter, we're going to add those up. 4 root 5 plus 4 root 5 plus 2 root 5 plus 2 root 5. All of the radicands and indexes are the same. These are like radicals. So 4, 8, 10, 12 root 5 would be our perimeter. All right, so change this up. Find the perimeter of the window if each small square was 6 inches instead of 5 inches. Okay, all right, so we're going to simplify first before we add or subtract. And here's what we mean by this. We do not have like radicands when we start. However, 18, 8, and 72 can all be simplified. Quickly, let me write down our perfect squares here again, at least the first few. We're only going to need through 36 because 18 is 2 times 9. 8 is 2 times 4, another perfect square. And 72 is 2 times 36, another perfect square. So the 9 gets to come out and be a 3. 3 times 6 root 2. The 4 gets to come out and be a 2. The 36 gets to come out and be a 6. Let's clean these up. 3 times 6 is 18 root 2. 8 root 2. 18 root 2. All right, and so what looked like at the beginning like we had non-like radicals, now it's all root 2, so we can add and subtract them together. Let's cancel out the 18s. 18 minus 18 will go away. And so 8 root 2 is left as our answer. So see if you can do the same sort of steps on understanding check number 3. Okay, second objective. We've added and subtracted. Now let's multiply. All right, and so same rules as our skills check. If we multiply, we're going to multiply by foiling. So let's see what we get. First is easy. 3 times 2 is 6. Outside, 3 times 4 root 5. We're going to multiply the 3 times the 4 and get 12 root 5. Inside, 2 times 2, 4 rad 5. And then last, we've got 2 times 4 is 8. And we can multiply the radicands as well. All right, that's the rule. We'll go 5 times 5 and get 25. So we've got 6 plus, these are like, so 16 rad 5. And then plus 8 times the square root of 25 comes out and is just 5. So you'll see the shortcut here. The square root of 5 times the square root of 5, which is the same thing as root 5 squared, turns into just 5. So that's 40. 40 plus 6 is 46. So 46 plus 16 root 5 would be our answer. See if you can do the same thing on number 4. Okay, so let's introduce conjugates here. So conjugates are going to be the terms that cancel each other out when you multiply. And the way they do that is it's exactly the same, but instead of an adding, you're doing a subtracting on the other one. So these two terms are conjugates, 2 plus rad 3 and 2 minus rad 3. When we multiply them, let's see what happens. First, outside, inside, last. Root 3 times root 3 is just going to turn into 3. Look at what happens. They cancel. It's 4 minus 3. This is our shortcut here. If we have conjugates, you're going to end up with just A minus B, right? Square root of A squared, square root of B squared. So 2 squared is 4, and root 3 squared is 3. If you put them together, final answer is 1. Use the conjugates on number 5. All right, last one here. We're going to rationalize these binomials. You are not allowed to leave square roots in the denominator. Okay, you have to have rational numbers in your denominator. Root 5 is irrational, not allowed. Here's how we get rid of it. We're going to multiply the top and the bottom of this fraction by the conjugate. So this is a minus. We're going to do the conjugate of the denominator on the top and the bottom. And then we're going to FOIL the top and FOIL the bottom. So foiling the top, 3 times 1, outside, 3 root 5, inside, 1 root 5, and last, it's going to be plus 5, all over. Okay, we know that this is a conjugates on the bottom, so we're going to have 1 squared is 1, minus root 5 squared is 5. Let's clean this up. 3 plus 5 is 8, plus 4 root 5, all over 1 minus 5 is negative 4. And we can reduce. 8 divided by 4 is negative 2. 4 divided by 4 is 1 root 5. And there's your answer. All right? You know you've done everything right if you've gotten rid of the fraction. Okay? I'm sorry, gotten rid of the square roots in the fraction. Okay? You can't have square roots in the denominator. You're done once all the square roots in the denominator are gone. So, see if you can rationalize the denominator on number 6. Any questions? We will go over all this in class. Good luck.